Thank you for the warm welcome, and thanks to everyone for being here when Patterson is talking upstairs. I assure you I'll inject as much comedy as possible into this talk to make up for it. Yes, I'm an engineering manager at a company called Ideon, where we are sort of the pipes between, we're health insurance, we're the pipes between the benefit administrators that you sign up with benefits with and the actual health insurance carriers. So yeah, if your claim is denied, it's probably my fault. Well, today we're going to be talking about the mutation game. Alan Turing called his Turing test the imitation game, and I call mutation testing the mutation game. And it's because it truly is a game. It's a game where I am trying to get my code and my tests to match up. I'm working with my code, I'm wrangling my code, and by the end of it, I'm usually trying to make sure that I'm actually smarter than the computer. So, all right, well, I can dig right in. We have an outline slide right now where I'll be telling you what we'll be talking about. So, we're going to be talking about, first of all, what is mutation testing exactly? I'll tell you about the benefits of it, why use it, what it's good for. We'll dig into the tools for mutation testing and how those tools work. So I'll do a little bit of deep dive there. Then we'll have a demo, assuming we can get the technical difficulties worked out. I'll go through some examples, some common gotchas, show you how it can be awesome and frustrating at the same time. And then I'll talk about the limitations and caveats of mutation testing so that you can know if it's right for your code base and whether you should implement it at work or at home. What is mutation testing? Basically, it's testing your code by altering it in silly or not so silly ways, and then you run your unit tests on that altered code. So what you're doing is basically confirming that your code works with the tests by changing up your code and seeing if your tests fail. So ideally, once you mutate the code automatically with your tools and run tests on that mutated code, your tests will then fail or raise an error. So if your tests still pass, then you have one of three outcomes. Outcome one is that that alteration to the code is a simplification that you can adopt. So right, it just makes the code simpler. Your code was doing too much and you don't want to test any more than that. Option two is that your tests do not cover the full functionality of the code that you've written. Right, so it's basically you've simplified your code with a mutation, but the tests aren't covering all the things that you want to cover in your code. Or the third option, or the third outcome, is that the alteration to that code is really quite silly. And so then you need to make a silly change to your test case to make this silly mutation fail that test case. Yes, thank you. All right, so outcome number three is where it really gets frustrating and annoying, and that's how that works. So you're probably wondering at this point, what the heck is this guy talking about? So let's just do a quick example. On the right, I have a method called getXman. It basically is just making a key and pulling a value out of a hash. And then I've written a spec for it. I define a hash here and then describe my method. And it gets an Xman out of the hash. Expects getting that person to return Kurt Wagner. Okay, this test looks good. This test certainly passes. But have I tested the output of this method if the key does not exist? Well, if I want my method getXman to handle nil or return nil, then I need a test case for that. Otherwise, what mutation testing is going to do is replace this hash access, the brackets, the brackets with a .fetch method. Hash.fetch will throw an error if the key is not present, and so that's a more specific method that I can adopt if I don't want to, if I'm just not worried about the case where the mutant is not present. So this is what mutation testing will catch for you. It'll catch cases where you have left parts of your code open to interpretation that you may not have intended, and give you the tools to simplify it, solve it, or test it if you need to. All right, so let's talk about the benefits of this. The benefits are that you get more complete tests. You know your code is covered. It's really more of, for one thing, you're getting code coverage a la SimpleCov. And so you don't even need a tool like that if you have mutation testing, because you are basically ensuring that your code is covered. In fact, it's really more of a functionality coverage than just a line-by-line code coverage. You also get cleaner code. You know that your code and your tests are lining up, and mutation testing kind of forces your code to be just smart, clean, without frills, and it still gets the job done. You also get like improved knowledge of Ruby and its inner workings. So mutation testing will really kind of train you and give you a better, deeper knowledge of like kind of what Ruby is doing under the hood. And it also trains your mind to code and test without potential mutations. So as you get better at this and do it more, you'll find that you're starting to write .fetch all the time instead of ever using hash access with brackets. You'll find that you're writing your code cleaner, and you're writing it so that it is just able to be tested smartly, simply, and easily. You also get increased unit test confidence. You know that your tests are lined up with your code. You know that your tests are covering everything that your code is doing. And really, flaky tests are all but eliminated. It's pretty hard to write a flaky test because mutation testing is doing a lot of different mutations onto each method and running that code through all your test cases. And so if you have a flaky test, it's really going to be caught by mutation testing almost certainly. So let's talk about tools for this. Really, the only complete tool for mutation testing in Ruby is the mutant gem. And I'll talk about crude mutant in a little bit. But the mutant gem uses the parser gem to parse Ruby code into an abstract syntax tree. So that's basically just a set of instructions that represents your Ruby code. Say if you're accessing a hash, it'll say, take the hash object, send the access to it, the access method to it with a string. The string is created by interpolating some stuff, etc. It's basically an abstract breakdown of what your code is doing in a more simple form. And so with that, the mutant gem has a giant list of potential mutations, which then it can monkey patch your methods with the mutations to that code. And then it runs the tests assigned to that subject, as I mentioned before. But it only runs the tests for that subject when it's mutating that code. So for example, if I have a method described Turing test, or a test case described Turing test, it's only going to mutate and run specs for that method specifically. It's not going to mutate other things that won't affect it. And so, of course, if my tests fail, then the mutation is killed. And then my mission is to eliminate all the mutations by adding more tests or removing or simplifying code, as I talked about before. So that's how mutant works. Crude mutant works mostly the same way. I think that's a much smaller side project. It basically works but instead of mutating code, it essentially just removes lines and sees if your tests fail with that. So that's kind of closer to the simple code coverage tools out there. All right, it's time for the demo. And for the demo, we're going to be playing a little game called Benedict versus X-Men. So, Benedict Cumberbatch, of course, from the movie The Imitation Game, and the X-Men, of course, because they are mutants, and we are mutating code. So, take a moment to familiarize yourself with the movies of each category, as shown here. Now, we want this to be a fair competition, so we will first check to ensure that the arrays of our data are the same size. All right. Website confirms that the arrays are the same size. We're going to be looking at Benedict Cumberbatch's last 14 movies, non-documentaries, and then all 14 of the X-Men movies to date. All right, well, let's check our code on this method and see if mutation testing tells us anything. So on the left, I have a calc class, which does a lot of very simple methods that are just implementing some very simple things. And on the right, I have a test suite for that class. This test suite is fully passing. So arrays, same length. We're just checking whether the first array has the same length as the second array. I will run a mutant command by doing it like this. I'm just mutating this method only. That's why I'm specifying with the after the double dash, I'm specifying arrays same length. All right, so mutant has given us a bunch of output here. You can kind of read into this stuff. It shows how many tests it found. So it found 6 tests. That's like all the tests for that class entirely. But you can see that it only selected 1 test, which was the arrays same length test here that I've created. And there were 20 different mutations that it tried. And let's see what it came up with. So there were 18 kills, but 2 mutations left alive. And so let's see what those are. All right, so what it's saying here is that I could change this line by replacing double equals with dot equal and get the same result. That is to say, my tests would still pass. Equivalently down here, it would say I can replace with .equal, and my test would still pass as well. Okay, well this makes sense because in Ruby, integers, an integer with the same number is basically a singleton and represented by this exact same object, VM wide basically. So essentially, .equal, which basically compares whether it's the exact same object, is more specific than the double equals up here. And so I can just replace that, and this will, since I know I want to compare two integers here, it'll always work that way. All right, let's mutate again. All right, still one issue. Aha, it's saying that I can just replace this entire line with true. Well, looking at this, I guess that makes sense because my test cases are only testing whether I get true out of this Boolean method. So really what I need to do is make another test case that actually returns false. Oh, I need to change that to false also. All right, one last mutation on this method, and now our mutant coverage is 100%. So we've been able, through that, we've been able to ensure that, like, all right, our method is fully tested. We've got a very specific check on whether these arrays are the same length, and we feel pretty good about this method. All right, now let's get into it. So, Benedict Cumberbatch's last 14 movies, or the 14 X-Men movies, which has the higher average box office? Who thinks Benedict? Raise your hand. All right, and who thinks the X-Men? Much more for the X-Men, and you are correct. It's fairly close, 530 million for the X-Men, 469 for Benedict Cumberbatch. You can tell that Benedict Cumberbatch was probably helped out a lot here by Avengers Endgame, but you know, that's how it goes. Let's look at our average method and mutate it a bit. So my average method here, it creates a sum, adds each value of the array into the sum, and then outputs the length, sum divided by the length. And my test on the right is just doing a quick test of some integers there. All right, my mutant is telling me there's some differences here. Let's scroll up a little bit. Oops, didn't mean to do that. There we go. I have this puts going on here. Now, this is an easy way for mutation testing to find code that you don't need in there, right? It doesn't matter what I can change this puts line to. It's not doing anything, and it's not being tested. So I can just remove this because I probably didn't mean to have it in there anyway. It's probably just for debugging. If you did need to have a puts or a logging statement in your code, then yes, you will have to have a test case saying that, you know, standard out or your logging class or whatever is receiving a message. The other note that mutation testing gave me here is that I could remove the .2f at the back here, but I want that .2f because I want, you know, float division, not integer division. So I realized the issue here is that I'm just doing all integers here, and I'm ending up with an integer at the end of my test case. So let me add a quick new one here where it does return a float, and that should probably solve it. Indeed, it does. All right, Benedict Cumberbatch or the X-Men, which has the higher median box office of their 14 movies? Who thinks Benedict Cumberbatch? Okay, a few more. Who thinks X-Men? Oh, I'm afraid a lot of you were wrong on this one. The X-Men movies were pretty consistently blockbusters. Benedict Cumberbatch's movies, some blockbusters, some not so much. Yeah. So you know, he did a lot of like smaller roles in kind of some smaller movies, I think, and we'll show the data in a little bit. But let's look at our median method next. I'm just taking an array here and finding the you know, sorting it, and then of course picking the middle value. And I have a easy test over here as well. Let's run mutant. Okay, the first thing I notice is that it's reporting I can just use .fetch. So same as hashes, arrays can use .fetch to ensure that index is in the array, and if it's not there, it'll throw an error. So let's just assume that, yeah, that's kind of what I want. So let's replace that with .fetch. Here's a funny mutation. It took array length divided by 2 and just replaced with the value 2, and I still got a passing test case. Well, that's funny because that worked here because I have a 5-value array, and I have equal, it's looking at the middle value, so divided by 2, the second 0, 1, 2, second index. So let me add something else in here. Let me just throw in something, I don't know, a little bigger maybe and see if that helps it. So the median here should be 4 now, and let's run mutant again. A little better, let's scroll up. It's saying I can go do away with the dot sort. Okay, so that makes sense because the test arrays that I'm using over here are in fact already sorted. So I can alleviate this by throwing something in there where, let me just kind of unsort them a little bit here. Make sure that I am doing that. One more mutant, and we're good to go in this method. All right, well, let's take a look at the actual data so that you can see that I was maybe being a little facetious or tricky with you because this Mowgli Legend of the Jungle for Benedict Cumberbatch, it was on Netflix, and so it had 0 box office. Similarly, The Power of the Dog, I think it must have gotten a limited release, so $700,000 of box office there. But of course, the big ones, Doctor Strange, nearly $1 billion, Spider-Man 3, nearly $2 billion, and then Avengers Endgame, $2.7 billion. Dr. Seuss the Grinch came out pretty high as well, and 1917, also good ones. But you can see with the X-Men movies, that was where the real hay was made. They started off strong, got even stronger, and then really came into their own once Deadpool came out. $700 million there, $700 million for Deadpool 2, and then Deadpool and Wolverine, $1.3 billion. So that they have amassed more than the totals for Benedict Cumberbatch there. All right, now you've all memorized those numbers, I'm sure. Which of these box office numbers are valid UPC codes? Any guesses of how many out of 28? Shout out a number. 3. 28. 7? The answer is 2, actually. I padded with zeros in the case that in the case that there was not enough digits to make an 8-digit UPC code. But only one movie, aside from Mowgli, came out with a valid UPC, and that was Deadpool 1. So, all right, let's look into our code for this then. So I've got a method that checks whether I have a valid UPC check digit for 8-digit UPC on an array. Let's see. To calculate a UPC code or check it, basically, you take the values in slots 0, 2, 4, 6, multiply them by 3, and then add the slots that are in the even parts, so slots 1, 3, and 5. Mod that all by 10, and then it has to equal the final digit. I used inject here and I didn't use it here. Don't ask me why. I'm a manager now, so I don't. It doesn't matter. And I've learned my lesson now. I've used .fetch to get stuff out of the arrays. I have written several test cases here that return true, true, and false on this Boolean method. I think I should be good here. Let's see what happens. All right, still 5 mutants alive. Let's see what happened. All right, interesting. So here it's replaced my 5 in this statement with 1, and it's saying I can still pass my test cases that way. All right, let's look. My test data has the same stuff in array index 5 as it does in slot 1 in every case. And so that's why it's saying like, hey, you can just use that. So here's a case where you have good data and you have good test cases, certainly sufficient test cases, but it's going to gamify you and make you like change things up a lot just in order to satisfy its weird mutations. So let me add 4 here, and I'll add 4 to the end of this as well. Let's try again. Okay, a little better. I got rid of that one. Same problem with index 3. That's fine. Let's just add 2 there, add 2 there. I'll scroll up and look at another one here. oh, here it's saying array fetch 1 can just be replaced with the number 1. Well, that's because I used 1 in every one index slot here. So, okay, let me just change this up as well. This is, if I had 3 here, then I should add 3 over here too. Let's scroll up a little bit more. Oh, it's saying with these integers here, I could change the 4 to a 0 and it still works. So, so any copying of data over here is like totally making it flip. And here's the part where I'm talking about, where it gets frustrating, and it's like, I know I have this tested right, but mutation testing is telling me I don't. That's the part you just have to deal with. All right, demo over. So let me just talk for a little bit about the limitations and caveats, despite the one I just talked about. The thing with mutation testing is that it'll slow your development down. This makes sense because you're being more sure and more certain of what you're doing, but you also have occasional unknown gotchas or hangups, not dissimilar to the one that I just showed, but also sometimes the mutant gem will throw up weird errors because of its threading. Sometimes it will just like freak out, and you have to like understand what's going on, what spec it's running, and find the error. Another thing is that it's slow. So you notice that it's running the same test suite a lot of different times for each mutation. And even if you do this just for the code that you change in a certain commit, which is how you should configure it, and it has options for that. But even if you do that, it can take just as long or longer than your normal test suite. So it's a slower process that definitely takes up cycles. And it requires code and tests with few or no external dependencies. This is okay though, because it kind of trains your mind for isolation. The mutant gem can mutate custom DSLs and mixins, but testing those can be confusing. It can also, it cannot mutate methods defined within a closure or an eval. So because you're dynamically defining those methods, the parser gem will not parse them out as part of the abstract syntax tree, right? Like it won't be able to know what's exactly in those methods because they're dynamically defined. And thus, even though you have a test case for them, it won't be able to find them in the code and change them up. Lastly, it's quite expensive, actually. The gem itself costs $90 per seat per month, although it is free for open source. And support and resources out there can be slim to non-existent. There aren't a lot of companies or coders really doing this as far as I know. But I would say this leaves some opportunity for someone to go experiment, write some blog posts. You can be the face of Mutant for the future. So the question then we end with is kind of, is this right for your code base? I think I would very much hesitate to inject mutation testing into a legacy Rails monolith that has lots and lots of models and classes. If I was starting something new, like a small microservice to the side of that, or even just a new project altogether, I think it would be a good thing to add, especially if you want to have, if you want your API or your service to have really rock solid dependability and error-free, confusion-free error reporting and everything like that. So, but yeah, again, like I say, I would hesitate to add to an existing code base, except for maybe incrementally. You might start with just your model files, or perhaps some lib classes that you know are smaller and easier to test. All right, here's my references. You guys can go play with the app at this address. I left the GitHub repo on there as well for you. And I just wanted to end with a final word. I had a very difficult week last week, but I found this quote by Professor X that inspired me. Just because someone stumbles and loses their path doesn't mean they're lost forever. Sometimes we all need a little help. It resonated with me, and I hope it resonates with you too. That's all for me. Thank you.